Okay, assignment 2, research methods. This looks at key issues in sport and exercise research, and essentially has two sections. We'll explain those. So again, this is looking at you as a researcher and the different types of research you might carry out, and some issues that you need to be mindful of when you're collecting data. Jumping on to show you the assignment brief then. Here's the mark sheet. You guys fill in the top element, I do the rest. The subject review sheet you must complete with your review at the bottom. Moving on to the front cover, and the image there you'll recognise from the video, and your scenario, criteria, 4 criteria. Please don't forget to complete your learner declaration, saying that it's all your work, the 2 tasks that you need to complete, and the important unit specification. Now this assignment you will complete inside this assignment brief. Task 1, here you're going to do this work. On task 2, here you'll do this work. So it's all pretty straightforward in this instance. So the unit specification then, again it's, as I suggested earlier, it's in 2 parts. Firstly, you're going to look at the different types of research that you might do as a researcher, quantitative and qualitative. And then the second task, you look at these 4 key issues to be very mindful of when you're carrying out research. Here are assignment criteria. It's kind of divided like this. So P1 is the task 1, P2, M1, D1 are all about those 4 key issues that we need to look at. And the scenario is based around the British gymnastics team, female performers actually, rather than the male in that image there. And you need to basically do some research on these performers, on these gymnasts, and present your findings. But you've got to be cautious about these issues whilst doing that, and that will all make sense. Task 1 then, qualitative and quantitative research. You need to do some research on this to help your understanding. I'll go over it very quickly, and make sure that when you explain it or describe it, you give your own examples of the sorts of qualitative or quantitative research that might be carried out. So, research, what is it to start with? It's pretty much a very structured, systematic process of finding out something, investigating something, studying something, with the aim to improving your knowledge, or sort of a bigger goal, a greater picture than that. It could be to do with medical research that helps in a larger scale. And it's very important in this research to bear these 4 things in mind. The research has got to be relevant. If there's no relevance to it, what's the point in doing it in the first place? It should be reliable in that it should be repeatable. It should be accurate, so the data you collect should absolutely represent reality. And this black objectivity word is very, very important. A lot of research can be biased either by the researcher or by the participants, and it's really important that we have things in place to make your research data collection and interpretation as objective, as factual as possible. And to do that, you need to try to control as many variables as you can. So take away things that might affect your results, that you don't want to affect your results. So we have 2 sort of generic or general types of research method that we're going to look at. Firstly, this one here, this one actually represents quantitative data or quantitative research, where you have some kind of theory, some kind of idea. You then state a hypothesis, what you're going to test. You collect your data, you make your observations, you get your numerical information, and from that data you can either agree with or disprove the hypothesis that you were testing. So it's all about the hypothesis in quantitative data. And you can see, because it's generally numerical, it's very objective, very factual. You're testing hypothesis, looking for differences or relationships in the data, and you're tending to look at what. You don't tend to look too much beyond that and look at why something is. You look at factual outcomes. This side then, we've kind of got the reverse. We start here. So this one was called top to bottom or top down. This one's called bottom up, because you start with the data that you observe. So you collect rich data from the subjects. You look at that data and see if there are any patterns or themes. You then draw your conclusions and ultimately your theory from that data. So rather than starting with the theory and trying to prove it or disprove it, you start with the observations and the data and build up a hypothesis from it. And this is qualitative, so you're looking at the quality of what has been shared with you. This is often very subjective and described as inductive, whereas this was deductive. You deduce something, you induce something here. And from the rich data that you get from your subjects, you can often give explanation. You get the understanding, the thoughts, the feelings, the opinions of stuff, whereas this tends to be a bit more factual. Task 2 then. So we're now looking at those 4 key issues that can affect research, and depending on the depth of your answer, you may achieve pass, merit or distinction. And the key verbs here are identify, explain, analyse. So what are the key issues in sport and exercise science? There are 4. You may recognise some of these words: validity and reliability, accuracy and precision. So let's go on to look at what those kind of mean. So validity and reliability. Let's start with validity. This is defined as, this looks at whether you're measuring what you're supposed to be measuring. So for example, if you were looking at the sit and reach test, it's not a measure of shoulder flexibility, it's a valid measure of hip flexibility or hamstring flexibility. And so you have to look at, does it actually measure what it's supposed to be measuring? And there are 2 types of validity. Internal validity considers, have you controlled all the variables during your experiment so that you can be sure what you're measuring is what you should be measuring? For example, if you were doing an experiment to consider the effect of mental rehearsal on free throw shooting in basketball, and some of your performers, some of your subjects, when they were doing the tests, taking their shots, some of them had an audience present, so people watching, and some didn't. Those with the audience present, you can't be sure that there is internal validity, because the audience may have affected the outcome. It might not just be the mental rehearsal affecting the outcome. So you need to control all variables to have internal validity. External validity looks at if the data and results can be generalized to sort of the bigger world, the bigger population. Reliability then looks at if your protocol is so good that if you repeated the test again in a week, 2 week, 3 weeks time, that you would get similar results. And reliability can look at inter-researcher reliability. So if I collected the data one time and a colleague collected the data another time, if there was reliability, those results should be similar. And also test-retest reliability. So it's really important that not only all researchers carry out the protocol and the data collection in the same way, but the test is so standardized that you go through exactly the same steps, that the same happens each time you deliver that test, and that will increase reliability. Accuracy and precision then. Sometimes a little bit confused with people. Accuracy looks at how close it is to its actual value. So if something is accurate, if let's say an athlete did 100 meters in 10.3 seconds, fact, and you measured it and your recording was 10.3 seconds, your recording would be accurate, or that method of recording, that stopwatch that you used, would be deemed accurate. If the athlete actually factually run 10.3 seconds and your stopwatch was measured at 10.7, that would be deemed inaccurate. Precision then, a little bit harder to explain. The degree of agreement of a measurement, so the sort of similarity of measures. And this is really quite closely linked to reliability. And there's an image in a minute which might make it visually a bit clearer for you. So if something is measured and gets the similar results each time you measure it, it becomes quite predictable. And if results are clumped together with the same kind of result, if you did 100 meters on multiple occasions and the same stopwatch was used and the same outcome was used, you got 10.3 every time, those results would be considered quite precise. If you got 10.3, 10.8, 11.2, then you could argue that that stopwatch and that strategy to collect data might be imprecise. So it's the fine detail. And also, if the results could be measured at 10.321, and it has that finer detail of results and information, that might be considered even more precise than if it just was rounded up, let's say, or something was measured and it was just 10. And this visual might help with that, really. So 4 targets. This target shows highly accurate because it's on the bullseye, it is what it is where it should be, and precise in that they're clumped together. There's a lot of predictability of where the outcome is coming. Here we've got precise because they're clumped together, they're similar, but they're inaccurate. They're not on target, they're not what it should be. Here we've got accurate in that they're on the right sort of lines, the right sort of area, but imprecise in that there's reproducibility error. They can't reproduce the same outcomes. There's imprecision, there's variability, unpredictability in that level of accuracy. And here we've got kind of the worst scenario. Inaccurate, not around the target, not what it should be, not measuring what it is, and variations in precision, so unpredictable outcomes off target. Hopefully this visual will make it a little bit clearer. So in the scenario of the Great British Gymnast, you're going to do several tests within your group. You're going to, in small groups, collect data from these tests, and we will put all that data together in a spreadsheet. And then just remember that when you're actually doing the test and collecting the data, to be thinking about how you're collecting the data, what protocols your group or other groups are using to collect the data, and if you think there might be any variables that affect your results that might make them different from somebody else, based on these 4 key issues that we've just talked through. So as again, when you're thinking about your data, and this will come up for distinction in your work, were your tests valid? Were your tests reliable? Were the results accurate? Were the results precise? Were there variables that were or weren't controlled in these tests? And did every group conduct the test with the same protocols? So I've just tried to throw in very quickly an example of how you use discussion and analysis of the tests and the data that you're collecting to show that you can analyse that and show your understanding of those 4 key issues. So let's quickly read. The standing broad jump data may be unreliable as different groups had different protocols. One group measured from their heels and another from their toes. The data was therefore inaccurate and varied between subjects. In these tests, if these tests were repeated at a later time, the variations in the protocols for this test would not ensure that results were similar. Further, the measurements for standing broad jump were subjectively determined by the observer watching landing positions, so this would decrease the accuracy and may have produced shorter or longer jumps for subjects. So we've used that particular test to draw out and to analyse based on reliability and the other sort of key issues. So just to remind you, this assignment has 2 parts. 1, describe qualitative and quantitative research, give your own examples. And 2, using the data collected and your experience of collecting the data, analyse, explain, identify those 4 key issues relating to that data.